Hey guys, and welcome back to my channel, and this week's video is going to be about exponential equations and how we solve them using logarithms. So in this video, I would like to touch on two very basic but also popular types of questions that you might encounter for which you could use logarithms to solve them, and how you can use your understanding of logarithms and exponents to put the two together and solve such equations. So for our first question, we have 9 to the power of x plus 2 times 3 to the power of x plus 1 is equal to 1. So our strategy would be to, whenever you can, use the same base. Then, once we have the same base, we could compare, and we would work with the same variables. In this case, we would use variable substitution, or I like to call it u substitution because it gets you familiar with a concept that you're going to later do on in calculus, but that's for another video. And then you're going to solve the equation. And I guess this is the most important step, where you then recognize the u substitution step. But let's see how this actually looks like, because it might sound a bit complicated. So, of course, you have to use your exponent rules in order to simplify this expression. And we start off by recognizing that 9 and 3 can be expressed with the same base. 9 is equal to 3 to the power of 2, so we can write it as this: to the power of x plus 2 times 3 to the power of x plus 1 is equal to 1. And if we want to only have x in our exponent, we know that 3 to the power of x plus 1 is the same thing as 3 to the power of x times 3, because this is 3 to the power of 1, and once we add them together, this is going to be equal to 3 to the power of x plus 1. So we can rewrite it as that. So we want to isolate the variable. So we're going to end up having 3 to the power of 2x plus 2 times 3 to the power of x is equal to 1. And if we simplify this further, we're going to have 3 to the power of 2x plus 6 times 3x equals to 1. And this is where this rather new step that you might be unfamiliar with comes into play. The u substitution step. Sorry, I highlighted the wrong part right there. So the u substitution is pretty simple. It just simplifies this equation so we can work with it as something that we're familiar with. So what I will write here is, let's say, let u equals 3 to the power of x. So now we rewrite this whole equation in terms of u. So 3 to the power of 2x is the same thing as 3 to the power of x to the power of 2, right? Don't forget the exponent laws. And so we write this as u squared plus 6u is equal to 1. If we simplify this further, we get this equation. And based off this, if you use the quadratic root formula, you know that u is either -3 plus or minus square root of 10. However, because we're working with then logarithms, because if we come back over here and you do not forget to go back to the fact that you're finding x and not u, now we can use this to find our x value. So we know that 3x is equals to -3 plus or minus square root of 10. And what we can derive from that is that x is equal to the logarithm base 3 of -3 plus or minus root 10. But wait, we can't simply leave this, because one of our answers is going to be a negative. In fact, if we have -3 minus root 10, we're going to have a negative value over here. And that cannot be, because the logarithm of a negative is undefined. It's not possible because our base is also positive, so we'll never get a negative from a positive. So over here, we have to erase this part and specify that this is only for -3 plus root 10. And I'll put a star next to it so you don't forget to do it. And this would then be roughly or approximately equal to -1.655. And we would leave it at that in this case. Sometimes these equations are easier to work with because you get a whole number, but in this case we're going to have to use the root formula. So again, just recall, our strategy is to first have the same base in all of them, and then further simplify the equation by using u, a variable, solving for u, and then substituting x back, because do not forget that you want the x, not the u, so that's why you have to go back to what you said here and solve for that, and this is where the logarithms come into play. Now, our second question is a bit different, and if you look at it, you might realize why. There's no way we can express 8 and 6 as the same base. It's not possible. Hence, we have to use a different strategy. We can't simplify and then use u, because we'll never, in order for us to use this u substitution, we have to have the same variable. This will not happen here. So what is our strategy? And in fact, in the instructions, they want us to express it with natural log and then whatever their argument is. We want to apply the natural log in this case, or any other log. This can be the same thing as like expressing it as log base 2, and then use the logarithm laws to solve for x. And then again, simplify. So how might we do this in practice? Well, first we take the natural log, because in this case we're instructed to work with the natural log. I'm just reminding you, you can pretty much take any log you want. It's just that this narrows our options down. So first we will take the natural log of both sides. So natural log of a to the power of x minus 1 is equal to the natural log of 6 to the power of 3x. And then if we remember, when we have an exponent, we can bring it out to the front over here. So this is going to be the same thing as writing as x minus 1 times natural log of 8 is equals to 3x times natural log of 6. And now we want to isolate the variables. In order to do that, we still have to multiply this bracket out. So we have x ln 8 minus ln 8 is equals to 3x ln 6. Now bring the x's to the same side. Again, this is basic algebra. Now we can factorize the x out. So x ln 8 minus 3 ln 6 is equal to ln 8. And then we have x is equals to ln 8 over ln 8 minus 3 times ln 6. But now if you look at this, we can't simply leave it at this, because the answer wants us to express this as natural log of 3 or natural log of 2. And so what we do is we recognize, using the basic logarithm laws, that the natural log of 8 can be rewritten as the natural log of 2 to the power of 3, which can be written as 3 times natural log of 2. So we can rewrite this as that. And once we do so, we're going to end up having 3 times natural log of 2 over 3 times natural log of 2 minus 3 times natural log of 6. We can cancel all of these 3's out. What else we can see is that the natural log of 6 can be written as the natural log of 3 times 2, which can be written as the natural log of 3 plus the natural log of 2. And where we go from here is write this as the natural log of 2 over the natural log of 2 minus the natural log of 3 plus the natural log of 2. These two cancel each other out, and now we have the natural log of 2 over the negative natural log of 3. And this is our final answer. So if we recall, our strategy was to apply the natural log to both sides, natural log, because this is what we have been instructed to do, but you can take any logarithm. And then we use the log laws to simplify this further, and if we have specific arguments, we use more logarithm laws to get the answer into the forms of those arguments. So I hope you enjoyed the video, and I hope you better understand how to apply logarithms to exponents, how to switch between the two, and when they're quite useful in order to solve equations with exponents. So I hope you enjoyed, and see you next time.